Hello everybody, welcome back to your channel Eco Engineering again. In this video I'm going to talk about how to implement object-oriented programming in Python. In the previous video and full tutorial for Python Basic, which you can find the link to that here, we explained how functional programming in Python works, how we can define function, how we can use them. But now we want to talk about object-oriented programming. I know that object-oriented programming can be a little confusing for those who are a beginner in programming, but I tried my best to explain it as simple as possible in this video. The first section of this video is this PowerPoint. I explained the object-oriented programming. I suggest you watch this section too. But the second section is programming and how we implement a code in our Python environment, which is a Jupyter extension in Microsoft Visual Studio. This is just a Jupyter IDE. I highly recommend you to watch both sections, but if you are only interested in the programming section, please skip this video to the minute and second that you can see below here to only watch the programming section. I hope you enjoyed this video and stay with me to the end, and do not forget to hit the subscribe button and bell button if you have not already done it. So the first thing is, what is an object? We have different definitions for objects. This is the most common one. Everything in Python is an object, and every object has a type. Objects can be numbers, string, list, function, modules, and more. The first time that I saw this definition for object when I was learning programming with Python, it was very unclear, and I had one question: what is object? And then everything was object, and it made everything even more complicated. So I searched for another definition for object. I found it on the internet. Objects are variables that contain data and functions that can be used to manipulate the data. So variables that contain data and functions. The object data can vary in type. There can be, for example, string, integer, double, float, everything, depending on how it's been defined. An object is like a mini program inside Python. They are mini program inside a variable with its own set of rules and behavior. I think the second definition is better, but still, we don't need these definitions. We need something more practical. Something more practical for object. I would say it may not be complete, but it is very helpful. Object is anything in Python that with a dot in front of it, when we press dot in front of it, some attributes and methods will be opened for it. So when you press a dot in front of something and some attributes, methods, and functions are opened for you, this is an object. I would go for it, and I accept it as a definition for object, even if it's not completely correct. So what does an object have? The first thing that they have is attributes, and then methods. The methods usually comes with parentheses. When we say for example choose a list and press dot in front of it, and we choose some methods for it with parentheses, they are usually methods. Normally we call methods in functional programming just a function. You know, even we have object-oriented programming, and in contrast we have a functional programming. In object-oriented programming, we call functions methods. So methods are very similar to function. I leave you the link for functions in Python here. If you don't know how to define function in Python, you can check it here. So, for example, we define a student class. And then we say student1 is equal to student class with a name and an age. For example, student1 is equal student, name is Peter, age is 32. Student2 is equal student, two parentheses, name is equal to, for example, team, at age is 25, and so on. We can define as much as student as we want, but we should have the class student defined before. And with student one, we have attributes. For example, we can say student one dot first name, then it will return as Peter. And then we can say student one dot age, and it will return the age that we entered here. If for Peter we entered 30, for example, it will return as 30. We can reach the attributes with just a dot and choose what we defined for it. Then we have methods. They are like functions. They do something for us. For example, if we say for student one dot score means, we can define for these score means in the student class that go and calculate the means of these student scores. For example, the means of all scores for mathematics, physics, chemistry. If you are, for example, you're studying computer science, go for database and all the courses that he already or she already passed, and mean all the scores. For example, it stood, or we can say like student one dot score mean, and we can have some inputs for it, and we can say, for example, do the calculation for last 2 years or last 2 semesters or last year. They are all can be defined in the class when we define the classes. Student one that absence number, it can, for example, return as how many days the students was absent. Or we can say, okay, students that days absence, the days that the students were absent, and the inputs for these methods can be start date and end date. Between these 2 days, go check the database and find out and return as the date that these students were not present in the class. But as a practice, in the next section, we define a class for dynamic list, and we try to have a dynamic list. We say my list is equal to dynamic list, and we can say, for example, my list 1 is equal to dynamic list, my list 2 is equal to dynamic list, and so on. For example, my list 10 is equal to dynamic list. And then we want to have the list size. We can have access to that by, for example, my list size, and it returns as length of the list. Or we can say my list that add element to add another element to this list or a number, or remove element. We can remove an element from our list. We can say mean list, my list that mean, and it calculate the mean of all elements in this list, or my list resize. For example, if at the beginning we decided to have a list with 4 elements, and in some case, in some points we decide instead of 4 elements we want to have 10 elements, we can easily do this resize by using this mylist.resize method to resize the list. This is how the object-oriented programming works. Yes, at the beginning it takes a lot of your time, but then when the project is very big, it helps you to make everything much easier. The difference between object-oriented programming and functional programming is exactly that. The object-oriented programming at the beginning takes a lot of your time, but then makes everything much easier for you by using the classes. In the next section, we implement this my dynamic list in Jupyter Notebook, and stay with me to the end. Welcome back again. In the previous section, I explained you how object-oriented programming works. Here in this section, we are going to implement a dynamic list with object-oriented programming and defining a class for it in Jupyter extension in Microsoft Visual Studio. This is exactly like the Jupyter notebook that it is web-based, but here we are using the extension in Microsoft Visual Studio. So the first thing that I do, I define a class by writing class, and the name is dynamic list and column. Then here we initialize our class by defining a function named def underline init, again underline, and here 2 parentheses. The first parameter always is self. The second parameter is the capacity. Here the second parameter we define for it. We want the user insert the inputs to initialize this dynamic list, and we want the user to enter the capacity, and then and it should be integer, and then we say higher limit. Again, it should be integer, and then lower limit, we want it to be integer 2. Then colon, we go into the init function to initialize the list, and we want to define attributes for this class. I'll show you how. We say self dot list capacity is equal to this capacity that is entered by the user. So we say list capacity self dot list capacity is equal to capacity, and then we say self dot list higher limit is equal to this input that is entered by the user. Again, we say self dot list lower limit is equal to lower limit entered by the user. Just an example, I want to show you how it works. So I shift and enter. Now I define a list. I call it my list one, and it is equal to this dynamic list here. It is equal to this dynamic list, and I say it's equal to dynamic list. It has 3 inputs. The self is not there. I tell you why we are using self, but we only have, after self, we have capacity, higher limit, lower limit. Capacity, higher limit, lower limit. I say, for example, I can say capacity is equal to 4, or I can just enter 4 for the first input of this function, this class, but it is an initial function. I just say capacity is equal to 4, and higher limit is equal to, for example, I want my numbers be between 100 and lower limit be minus 100. This is my higher or lower limit, and if I press shift and enter, this my list now is an object from dynamic list class. And if I press dot in front of it, I can have access to list high limit, list capacity, list low limit. If I call list capacity, it will return as 4. Because here in our list, we said, okay, list capacity is equal to capacity, which is entered by the user. We entered it here. And I can have access to my lower limit, and it is equal to this lower limit that the user, which in this case it was me, I entered minus 100, and now we have minus 100. This is how we define the attributes for our function. I don't delete it, I just go inside this one. And now I want to have another attributes. It is my list. I call it self dot list, and it is equal to 0 multiply by this self list capacity. If I multiply it by this capacity, it would be the same, but after initializing the class, not anymore we work with the capacity. We try to use with this self that list the underlying capacity. All of them together are a variable, all of them together, okay? What does this one mean? Well, we can check it. If we say, for example, 0 multiply by 4, it will return as an array with the size of 4, which all elements of this list or area, each of them is 0. So here we are doing the same. If the user wants to have a list with 4 elements, we initialize our list with 4 zeros. If I press shift and enter, run this one again. Now, if I call my list one and press list here, if I press list, it will return as 4 zeros. If I enter 10 here and press shift and enter, again shift and enter, it will return us 10 zeros. Now we want to add some methods to this class, and now we say def add element, and we should enter self as a first input here too. I'll tell you why. Then I want the user enter the index number, and it should be again integer, and number, you can say number to add, and it should be integer 2. But we go inside the add element function, we say if the number added, now the number that user wants to add to this list is greater or equal to this self list higher limit, because we don't want the user enters a number higher than 100, for example, in this case, because the higher limit is 100. We want to say if number to add is greater than higher limit, then column say self dot list higher limit. We want it to be equal to 100 in this case, because we entered higher limit as 100 here. So, and we want to have another if, I copy and paste it for lower limit, and we say if our number is less than or equal to self list, here it is lower limit, and if the number that is entered by the user is, for example, minus 200, we enter minus 100 to our list, not minus 200, because we have a lower limit and higher limit. But if we don't have this self here and we just write it like that, then we will not have access, because you can see that now the colors of this high limit and low limit has, both of them have changed, because we have not used this self here. If in the methods we start with the self, we enter the self as an input for the for our method, then we can have access to all variables which were initialized in our init function. It's very important to have access to this self list capacity, self dot list higher limit, which all of them are now the attributes of this class. To have access to them in our methods, we should start our inputs by a self in the methods. So this is it. And now we want to add this value to the corresponding index. So we say this is our list, self list. Here we should say self dot list with capital list, self dot list, and we want to change this index equal to the number which were entered by the user, like that. This is how we define this method. To add element, I shift and enter. Again, I define my first list. This is my list. And now here I say my list one dot add element. The first index number, I want to add it to index 2, and the number I want to add 48. And now I call my list dot list. To say it, I can see that number 48 is added to index 2. This is 0, this is 1, and this is 2. I can add, if I add, it's already added. If I run this cell again, and for example, I want to now add to index 6 minus 20, if I press shift and enter, both of them are added. This is 48 and this is minus 20. We can have another method and we call it def remove element and self index integer, and just like that. Then we say self dot list index. This index I want I want to from this list dot pop, because we wanna remove an element which is located in this index, and then I define another method named min, or we can just call it get min self. And in this case, I say calculate the sum of elements located in self.list and divide it by length of self.list. This is how we calculate min, and I wanted to return this value for us. And then get max. This is another method. It's very easy. We say, okay, return as maximum of self dot list, and we can have another, let's have some space between them, another for get main method, and we define self because we want to have access to this self list, which is initialized in our init function. Okay, that's why we always use self. And I want to return mains of our list, which is saved in the self.list. Shift and enter. Our class is defined. My list 1 is equal to this dynamic list. The capacity is 10. Like that. Only minus 20 is added. I can add to the element 1 with the index 1, add, for example, 42. Then to the third one, 80. And to the fourth one, for example, I want to add 225, but it should only add 100. Only 100 is added, and like that. And now I want to use my list 1 dot get minimum. It is minus 20. I can get mean to have the mean of all the numbers. It will calculate it. We have an error. Here in this list, I used self.list. It should be with capital S, like that. And now that I changed this list to the capital list, if I run it again, it should return us the mean of all the values. It would be 20. It adds all of them together and divide them by the length of the list. This is how we work with the classes, and we do object-oriented programming. We use def init function to initialize our class and define our attributes, and then we use methods to do whatever we want. But in order to have access to all of these attributes that are defined in our initialize init function in our method, the first input for our method should be defined as a self to have access to all of the self which are defined here. And but still, do not forget that this is the whole of this class is just like a template that we used it for my list 1. I can use it for my list 2 and say it is equal to dynamic list. And again, like in this case, the capacity I want it to be 4, then the higher limit I want to be 20, the lower limit I want to be 0. And we have both of these, my list 1 and my list 2, both of them are now from this dynamic list class, and this template is written once and we can use it hundreds, thousands of times if we need it. I hope you enjoyed this video. Please, if you enjoyed it, do not forget to hit the like button so you will help us to be introduced to those who are interested in these topics by YouTube algorithm. I wish you have a good day. Goodbye.